This is Algebra 1, Unit 8, Lesson 2 on the shifted form of a parabola. Okay, now we've done the standard form of a parabola, which is y equals ax squared plus bx plus c. Now, it has some advantages from when we look at this, because we know, for example, the c value would be the y-intercept. But can we tell where the vertex is from this equation? No, it isn't. The turning point is not obvious from this. So in this lesson, we're learning about a form of a parabola where the turning point is fairly obvious. So first, though, a review of simple parabolas. Okay, so if I wanted to sketch y equals 2x squared, first of all, on my axes, which way is this parabola going to point? Well, look at the leading coefficient right here. The leading coefficient is 2, which is a positive number. Which way is the parabola going to point? It's going to point up. All right, so if I have y equals 2x squared, and we have ax squared, the turning point has got to be at 0, 0. So if my turning point's at 0, 0, this is going to point up like this. Okay? Now, if we have y equals negative 3x squared, negative 3 means that the parabola is going to point down. It's still going to have a vertex at 0, 0, but it's going to point down like this because the a value leading coefficient is negative. So when you have just y equals ax squared with nothing after it, the vertex is always going to be at 0, 0 for both of these. Okay, so now what we're going to look at is shifting the parabola. All right, so we're going to consider the basic quadratic function f of x equals x squared and the more complex quadratic g of x equals x minus 2 squared minus 4. So they've already graphed y equals x squared, which is right here, or f of x equals x squared. That's this one. So what we want to do is we want to use our calculator or Desmos that works on both of them. We're going to put this in. I already have y equals here. I already have x squared in here, and I put in parentheses x minus 2 squared minus 4. Notice I used the parentheses when I did this. All right, now, when I graph these, it looks like this. Okay? Now, what I want to look at is the turning point. The turning point on the blue graph, which is right here, is at 0, 0. All right? Where is the turning point for the red graph, which is x minus 2 squared minus 4? Well, that would be at this point right here. All right? It would be at 2, negative 4. That's where the turning point is. So how did we get from here down to here? Well, let's see. Ooh, I hit the wrong button, sorry. Okay. All right, so it's not going to fit here, is it? There it goes. Okay, so it's going to be over 2 and then down 4. 1, 2, 3, 4. It's going to be right there. Okay. All right, so we went to the right 2 and down 4. So that's what we did. So if I did that from here to here, I wonder if that'll work for every point. Let me see. Right 2, 1, 2, down 4. 1, 2, 3, 4. Look at that. All right, this point right here, right 2, 1, 2, 1, 2, 3, 4. All right, this point right here, right 2, 1, 2, down 4. 1, 2, 3, 4. Okay, and then this point right here, right 2, 1, 2, down 4. 1, 2, 3, 4. Oh, look at that. Have we created a parabola? We have. Let me change the color so you can see it. All right, so there's my parabola. It goes like that. Does this look like the one that's on the calculator? It does. So what we did for this formula is we shifted from this parabola to this parabola. We took every single point and went right 2 down 4, no matter where I picked it. Right 2, 1, 2, down 4, 1, 2, 3, 4 is down there. You can see every single point worked. All right, now, so we knew that, whoops, this is going to be 2, negative 4 is going to be your vertex. All right, now let's write the equation of this parabola down here. Where's my color? Okay, we have y, or g of x equals x minus 2 squared minus 4. Do you see 2, negative 4 in this problem? I do. 2 right there is the 2 right there. Negative 4 here is the -4 here. Now notice the sign here. The sign is going to be opposite for inside the parentheses. So if this is 2, this is going to be -2. If this is -4, this stays -4. So whatever's in the parentheses is always going to be the opposite sign to tell you where the vertex is. This is where you find the vertex. Okay, so the vertex is at 2, -4. In this form, this is called vertex form of the parabola. So the form is g of x, or any function, is going to be a times x minus h squared plus k. That's called vertex form of a parabola. So this is vertex form. hk is the vertex. So when you see a parabola like that, this hk will always be the vertex of your parabola, and it tells you how to shift. Okay, now let's look at a more specific kind of shift. Let's look at the parabola y equals x squared again. And this time we are going to look at the functions x squared plus 2 and x squared minus 4. So I already put x squared in my calculator, or you can do it on Desmos. I put it in number 3 so it looks like what's on the paper. All right, let's look at x squared plus 2. Y equals x squared plus 2. All right, if I graph this, all right, the black one is the original, the blue one is x squared plus 2. What happened to the parabola? Well, it shifted. This is 0, 0. It went up 2. And let's see if we can get that to reproduce on the paper. All right, so this is 0, 0. The original, go up 2. 1, 2, puts me right there. All right, this point right here, up 2, 1, 2, puts me here. All right, let me do it on the other side. This point right here, up 2, 1, 2, is right there. Oh, this is working quite nicely. From here, up 2, 1, 2, is right there. And from this point right here, up 2. All right, so I have created g of x equals x squared plus 2. All right, so what was the overall effect of adding a constant to the function? Well, when we did y equals x squared plus 2, we shifted up 2. Now notice the plus 2 is right there, so that means we shifted up 2. All right, now let's look at x squared minus 4. Let me do a different color so I know which one I'm doing here. Y equals x squared minus 4. Let's see what that does. Can anybody predict what you think it's going to do? Well, let's take a look and see. Go to y equals. I'm going to go down to y2 here. I'm going to put in x squared minus 4. And graph that. So comparing it to the black one, we went to the red one. What happened? You went down 4. 3, 4. We're going down 4. So we're going to shift down 4 for this one. Let's see if we can reproduce the parabola. Shifted down 4. So I take this parabola, 1, 2, 3, 4. There's my vertex. This point right here, 1, 2, 3, 4. This point right here, 1, 2, 3, 4. This point right here, 1, 2, 3, 4. And this point right here, 1, 2, 3, 4. So if I draw my parabola, you can see really quickly that these two parabolas, this is y equals x squared minus 4, and this one is y equals x squared plus 2. So we can see the coordinates of the turning points. X squared plus 2's turning point is at 0, 2. X squared minus 4's turning point is at 0, -4. So can you see where the turning point is going to come from on this? If we have x squared minus 150 right here, what's your turning point going to be? Well, your x value is going to be 0. We're going to shift down 150. So if you have anything attached to the x squared out here, that's the k value. That's going to tell you how to shift. So this is going to be 0, -150 will be this shift. So if it's outside the parentheses, there's nothing on the x squared here in parentheses. Outside the parentheses here is going to be up or down. Plus means up, and minus means down. So this is up, this is down. Okay, Now, let's see what happens when we shift y equals x squared and do something to the x plus 3 squared and x minus 1 squared. So let's take a look at our calculator. And I already have y equals x squared in here, and now I just put in y equals x plus 3 quantity squared. Okay, now when I graph this, if you're affecting the x, which direction should you be going? Well, left and right. X is the x and y x-axis, goes left and right. But if this is x plus 3, let's look what happens. How did we shift? Instead of going to the right, we went to the left. So this actually shifted 3 to the left. So if I take a look at my graph, and I put it on here, let me do my graph. All right, and I'll do the blue so it looks like this. 1, 2, 3 ends up over here. This point, 1, 2, 3. This point, 1, 2, 3. This point, 1, 2, 3. And this point, 1, 2, 3. Okay, so there we go. Y equals x plus 3 quantity squared. Okay, so when it's x plus y equals x plus 3 squared, it's counterintuitive because this it shifts 3 to the left, and we should expect it to go to the right if it's plus 3. So what do you think is going to happen for y equals x minus 1 squared? Well, let's see if we can predict. If it's going to be opposite direction, so it's going to be opposite direction, which way do we think it's going to go? It's going to shift how? Well, it's going to shift 1, but instead of going to the left, it's going to go to the right. So it's the opposite sign. That's why it's counterintuitive. So if we graph this, let's verify that. Y equals x minus 1 quantity squared. And if I graph that, you can see it actually does go 1 to the right from here. Each of the points moves 1 to the right. So let me do it in red. Over 1. This one ends up over here. This one ends up over here. This one ends up over here. And this one ends up over there. So when I graph this, whoops, pretend I can draw a curve. When I graph this, it goes like this, and it shifted 1 to the right. So this is y equals x minus 1 quantity squared. This one is y equals x plus 3 quantity squared. So the coordinates of the turning points, notice if this is x plus 3, the turning point is now right here at -3, 0. -3, 0. Opposite sign. Okay, and then x minus 1 will be right here, is at 1, 0. This is going to be the opposite sign again. So when you do the x coordinate, it's always going to be the opposite sign. The y coordinate is going to be the same sign. Okay, now, determine the coordinate of the turning points of each of the following quadratics. Note the value of A is irrelevant, so it doesn't matter what's in front of here. What should be the vertex of this? The vertex of this should be at, the x value is opposite, will be 8. The y value is the same. So this is the y, and that is the x. All right, so this is going to be 8, 5. So the shift on this is going to be right 8 and up 5. That should be the shift. All right, what should be the vertex of 5 times x plus 1 squared minus 4? We're not worried about this. We're just worried about the vertex. So the vertex for this, opposite x, -1, same y, -4. So the shift for this should be to the left 1, down 4. Okay, and then this one over here, y equals -2 times x minus 3 squared minus 10. The vertex or turning point is going to be at opposite this is the 3. Same this is -10. So the shift for this is going to be right 3 and down 10. So inside the parentheses is left and right, opposite direction of the sign. Outside the parentheses is the y coordinate, plus is up, minus is down. So that is how a parabola shifts in y equals x squared to what's called vertex form.